All right, so in this video, we're going to go through sample question 55 from the Society of Actuaries ExamP list of sample questions. So the question reads, an insurance company's monthly claims are modeled by a continuous positive random variable x, whose probability density function is proportional to 1 plus x, not 4, I guess I didn't copy over the question correctly, to the negative fourth, for an x value between 0 and infinity. We need to calculate the company's expected monthly claims. All right, so pretty simple question. The first thing we're going to want to deal with is this. We're given a random variable whose PDF is proportional to 1 plus x to the negative fourth. Now what that means is that there's the actual PDF is some constant k multiplied by the expression they gave us. So the PDF is actually k multiplied by, I'm just going to switch these to a 1 plus x, or sorry, x plus 1 to the negative fourth. This is the actual PDF. And we need to figure out what this constant is before we can really do anything with it, like calculate the expected monthly claim, right? This is just an expected value question with an extra step at the beginning. So how do we go about doing that? Well, if we integrate over the entire region, since this is a probability, since that will get us a probability, and the entire probability of the whole sample space should be 1. So integrating this from 0 to infinity should get us 1. And that's what we're going to use to help figure out what k actually is. Simple enough. I'm going to factor out the k, or not factor out, I'm going to take the k out of the integration because it is a constant. 0 to infinity of x plus 1 to the negative fourth. Okay, and then I'm going to do U-Substitution. Right? If you need a refresher on integration techniques, U-Substitution and integration by parts, I have videos on that. And there are plenty of other great videos on the internet for that reason. So u is going to be equal to x plus 1. du will be equal to 1 dx. And I make my replacement. 0 to infinity of just u to the negative fourth. Integrating, I'll get 1 is equal to k, and that's going to be negative 1 over 3 u to the negative third. And I'm going to put the x plus 1 back in. So 1 is equal to k, negative 1 over, just make sure that's in frame, there we go, 1 over 3 multiplied by x plus 1, and then that's to the negative third. 1 is equal to k, and then I evaluate, right, because this should be from 0 to infinity. I evaluate, and that's negative 1 over 3. And then I'm essentially plugging in infinity, right? Infinity plus 1 to the negative 3 minus negative 1 over 3, 0 plus 1 to the negative third. This will essentially be 0. This whole bit will become negative 3. So 0 minus negative 3 is positive 3. We're left with 1 is equal to 1 over 3 k. K is equal to 3. All right, so now that we've essentially found the proper constant to multiply by, our actual density function is the following. F of x is equal to rather than k times, 1 plus x to the negative 4, it's 3 times, I'm going to just write x plus 1 instead, to the negative 4th. Now we want to calculate an expected value, right? We're going to want to calculate e of x. Easy enough. Expected value for a continuous would be, we're going to go over the entire sample space, so 0 to infinity. X multiplied by the PDF, which is 3x, 3 times, x plus 1 to the negative 4th dx. I'm going to do the same thing in the beginning of taking the 3 out. So I have now e of x is equal to 3 multiplied by 0 to infinity x plus 1 raised to the negative 4th power dx. And what do I want to do here? I will have to use U-Substitution, but what do I want to substitute? Sorry, sometimes it's not so obvious to see. Okay, I see it. So if I make u equal to x plus 1, right, just like before, so I'll kind of write this up here. U is equal to x plus 1 du should just be equal to dx. I'll end up with this, 3 still on the outside, multiplied by 0 to infinity of, since u is equal to x plus 1, x should be equal to u minus 1. U minus 1 multiplied by, this is obviously u to the negative 4th. And I can distribute that. This is equal to 3, and then 0 to infinity. My God, that's the worst infinity I've ever made. I'm so awful at writing the infinity sign. That's such a weird thing to not be good at, but I don't know, something goes wrong with my wrist. Okay, now this, hopefully, I don't need to do every single step out. This should be easy to see. This ends up being the following. We end up with, separating these out. We're going to do negative 1 over 2 times x plus 1 to the negative 2nd, evaluated from 0 to infinity, minus negative 1 over 3 multiplied by x plus 1 to the negative 1 over 3, also evaluated from 0 to infinity. All right, this is something we figured out before. That's negative 1 over 3. This is going to follow kind of a very similar pattern, and that's going to be 1 over 2. Okay, so this is now equal to 3 multiplied by 1 over 2 minus 1 over 3. And that, I'm just going to put in some of my calculator real quick. Okay, and we are left with 1 over 2. Lines up with answer choice C. Okay, so the hardest part about this question was the integration, really. It was kind of weird, especially that one bit in the middle here. So, quick overview. What were we given? We were given a PDF that's proportional to an expression. When that happens, we want to figure out what the actual PDF is. So, anytime they use the phrase, whose probability density function is proportional to given expression, multiply that given expression by a constant, integrate over the entire sample space, set it equal to 1, figure out what the constant is. Okay? Once you figured out what that constant is, multiply that to the original expression given, and you'll have the actual probability density function. From there, you do what they ask, right? In this case, it was calculate the company's expected monthly claims. Expected value for a continuous distribution, you integrate. It's going to be the amount multiplied by the PDF. And from there, it's just integration. Be familiar with U-Substitution. Be familiar with integration by parts. Know how to do it at a really high level. Better than how I did it. I kind of went really slow, in my opinion, for this question. You got to be quick with it. Sharp. If there are any questions or anything you want me to clarify, leave something down in the comments. I'll answer your questions to the best of my abilities. If you want to see more questions like that, I have a playlist solving these sample ExamP questions. If this video helped you out, hit the like button, subscribe, that totally helps me out. But other than that, good luck.